Okay, are you able to see screen?
Yes, sir.
So, as per the yesterday lecture, what we have seen is that what is stress and what is the fluctuating type of stress. That is nothing but again we have seen three types of that: fluctuating type, then reverse type, okay, and completely reverse stress. After that, we have seen fatigue failure. Just we have seen the introduction of that fatigue failure, and in that case, we have seen how the fatigue failure occurs well below than its strength of any material. We have seen this may happen in case of metals as well as polymers as well as other materials which we are going to use in manufacturing of any component, machinery, or any structure. So that type of failure will occur, and we have seen some properties of that fatigue failure, that how that fatigue failure is going to occur. So furthermore, the fatigue is a catastrophic, okay, and insidious, that is incidents occur uh, very suddenly without warning. So this property which we are going to see here for the fatigue failure, that is very dangerous, because this without warning thing is very dangerous from the design point of view, also from the application point of view. So this failure may not give us hint before it get occur, and which may create a large breakdown in case of any component or machinery where we are going to get this type of failure. Okay, but if we are going to do it deliberately, that is nothing but if we want to have the fatigue failure, like if you are going to break the, yesterday we have taken an example that if you want to break any wire, at that time we know that we are doing all the things, reverse stresses we are going to apply on that for getting that to be break. But if suppose we are going to use such type of or any component in some machinery where repetitive types of stresses will get induced in that case, it may be possible that this catastrophic failure will start, and suddenly that part may get break without giving any warning. And for this thing, we are going to have nowadays, we are using one more technique that is called as condition monitoring. That is nothing but we are always monitoring the condition of some important parts in that machinery where it is possible to have the breakdown, like in case of bearing or in case of gears or the fighter planes or space vehicles which we are going to use. Just a minute. Where the fatigue failure may be occurring and which is dangerous. Hello, am I audible?
Yes, sir.
Okay. So what I was talking about is the failure which may occur without giving any intimation, such as the applications, space applications. In space application, condition monitoring technique is used. Now, again, if you see in depth, the condition monitoring technique has it. Okay, it is separate topic that how the condition monitoring is done, how the prediction of fault is done. That is different part. But it will be helpful for us for such type of failures, that is fatigue failure. Then fatigue failure is occurring just like brittle material, that is without having any elongation in that component. Though the ductile material is used for that component. Are you getting me what I am saying? The property of ductile material is that first of all it will get elongate, and later on it will get break. And property of brittle material is that it gets break without elongation. That's why we are saying that ultimate tensile strength is there for the brittle material, and we are having two different graphs also, stress strain graph for the brittle material and for the ductile material. So ductile, in case of ductile material, neck formation may happen, but that is not going to happen in case of brittle material. But in such type of condition where repetitive types of stresses are acting or fluctuating stresses are acting, in that case, this ductile material also will behave like a brittle material, and it will break like a brittle material without having a neck formation and without having elongation. Okay. So this is what about the fatigue failure. Okay. And this fatigue failure mechanism, if you are going to see this last point, that in case of this fatigue failure, first of all, the initiation of crack starts. And then afterwards, this crack get propagate inside that material or that component, and propagation starts. And when the propagation of crack is occurring, then ultimately the failure will occur for that component. We are going to see various examples of such type of failures. Okay, but the mechanism, you can say that first of all, crack initiation, crack generation in that component, then it gets propagate, and then afterwards failure. That is, in 3 stages, this type of failure occurs. Is there any question? I mean, yesterday's lecture, what we have seen is how the fatigue failure will occur below its strength. That is, we have taken example of this small wire where we are going to apply positive and negative cycles of stress, that is compressive and tensile stress. So we are going to apply repetitive type of stress. Instead of having this plane shear, this failure will occur well below than its shear strength or tensile strength. Okay. So this is one more example. That is what about I was talking is the fatigue failure is characterized by 3 stages. And these 3 stages are the first of all crack initiation. That means somewhere that crack gets initiated because of the application of external force and the stress which get induced in that component. Then this crack get propagate, and later on finally failure will occur. Now here you can see this picture of crankshaft where the failure has occurred in this crankshaft. Now crankshaft is the main part which you are going to use in reciprocating type of engine. Now this crankshaft, which is where we are going to connect the bearing, okay, and later on with bearing we are going to connect it with the connecting rod, and it is connected to the piston. Now let me ask one question, that whether the crankshaft undergoes to the repetitive type of stresses or gradually stress will get induced in the crankshaft. I'll repeat my question. क्रँकशाफ्ट मध्ये रिपीटेटिव्ह टाइप ऑफ स्ट्रेसेस जनरेट होतात का ग्रॅज्युअल टाइप ऑफ, जसं की नकल जॉइंट मध्ये किंवा क्वार्टर जॉइंट मध्ये किंवा एखाद्या ट्रॉली मधल्या ड्रॉबर मध्ये, तसं क्रँकशाफ्ट मध्ये कुठल्या टाइपचे स्ट्रेसेस जनरेट होतात. म्हणजे I am saying type depending upon that static and dynamic, or fluctuating type or constant type. If you have got my question, then anybody of you can give answer. Otherwise, I will ask. Avinash Madne.
Hello. Avinash Madne, will you please unmute yourself? Am I audible? Hello. Am I audible? Atharo Kulkarni.
Yes, sir.
Okay, I am audible now. Now I am asking to Avinash Madne. Please unmute yourself. Avinash Madne. Okay. Then Aman Mulani. Can you hear me? Aman Mulani. Hello. Who can give answer? Nana Sahib Shinde. Hello. Nana Sahib Shinde, can you hear me? If I got my question, will you please answer me? Bagul. Sandeep Bagul.
Yes, sir.
Can you give answer that which type of stresses will get induced in connecting crank rod, crankshaft? Crankshaft बघितलंय का?
Yes, sir.
ओके ठीक आहे. कुठल्या टाईपचे स्ट्रेसेस त्याच्यात इंड्यूस होणार? रिपिटेटिव्ह टाईप, फ्लक्च्युएटिंग, दॅट इज फ्लक्च्युएटिंग टाईप ऑफ स्ट्रेसेस और नॉर्मल स्ट्रेसेस?
Repetitive, sir.
रिपिटेटिव्ह. कशामुळं?
Rotating, sir.
Rotating, but if suppose we are saying that the shaft which is connected to the centrifugal pump, सेंट्रिफ्युगल पंपला जो शाफ्ट जोडला जाईल मोटर कडून, त्याच्यात मग रिपिटेटिव्ह होणार का? इफ इट इज रोटेटिंग, इट इज ऑल्सो रोटेटिंग, बरोबर आहे?
Yes, sir. Fluctuating.
त्याच्यात पण फ्लक्च्युएटिंग होतील का? पिठाची गिरणीमध्ये जो शाफ्ट जोडला असेल त्या गिरणीला, त्या गिरणीमध्ये रिपिटेटिव्ह टाइप स्ट्रेसेस असतात का नॉर्मल स्ट्रेसेस असतात?
Repetitive असतात, सर.
रिपिटेटिव्ह का? एक्सप्लेन करू शकाल का?
Yes, sir. It is rotating on that shaft. Simultaneously, sir.
Simultaneously, if they are rotating it, why the stress will get induced? Anybody else? Okay, please. We have two situations. One is the shaft which is connected. You please unmute, mute yourself. Nana Sahib Shinde, unmute yourself. Nana Sahib Shinde. Hello? Nana Sahib Shinde, otherwise I am going to remove from my class. Already you have entered once again. Will you please unmute yourself? Akash. Akash Asgar.
Yes, sir.
We have discussed two situations. One is crankshaft.
Yes.
Second one is the shaft which is connected to the floor mill. So in case of floor
Yes,
mill, which type of stresses will get induced, and in case of crankshaft, which type of stresses will get induced?
In case of floor mill, sir, repetitive stresses are induced.
Repetitive. Okay. Can you explain
Yes.
how the repetitive type of stresses will get induced in the floor mill? What is the condition for repetitive stresses? Compressive tensile. Compressive tensile. That type of stresses has to be induced. In case of floor mill, what is the condition that we are going to apply load as a compressive load first, then tensile load, then compressive, then tensile. Though the shear stress will get induced, if you are going to see the principal stresses, in case of shear stress, basically they are principal stress, right?
Yes, sir.
But principal stress are two stress only, either tensile or compressive.
Yes, sir.
So in case of floor mill, how you can explain that it is converted into tensile, later on compressive, tensile, compressive? फ्लोअर मिल मध्ये असा काय लोड आपण अप्लाय करतो जो टेन्साइल क्रिएट करतो पहिल्यांदा, परत कॉम्प्रेसिव्ह करतो, परत टेन्साइल, परत कॉम्प्रेसिव्ह, असा लोड अप्लाय करतो का आपण?
No.
Can you give me any example other than crankshaft where the repetitive type stresses will get induced? So that I can what the repetitive stresses are.
Yes, sir.
Can you give me other example? Have you seen Portland that breaks the stone?
Yes, sir.
Which type of stresses will get induced in that breaker? Whether it will be repetitive type,
Compressive.
only compressive.
No, tensile and compressive.
Tensile and compressive. Okay. Again, tensile will not get induced because when you are going to remove force, zero stresses are there. Then we are going to apply force, then remove, then apply, then remove. Okay, partially it is right. That is repetitive type of stresses, or fluctuating type of stresses will get induced in that. Right?
Yes, sir.
Okay. Any other example?
Yes, sir.
Like I have given you two examples. Any other example?
In
मिरची कांडप यंत्र असेल त्याची जी वरची पार असते त्याच्यामध्ये कुठल्या टाईपचे स्ट्रेसेस इंड्यूस होतात? फ्लक्च्युएटिंग.
yes, sir.
ओके. शिलाई मशीन आहे, शिलाई मशीन,
Yes, sir.
त्यातली जी सुई आहे, which type of stresses will get induced in that?
Fluctuating.
Fluctuating. Okay. One more example. आपण हातानं पारेन दगड फोडतो ना,
Yes, sir.
which type of stresses will get induced in that?
Fluctuating.
Fluctuating. Any only you, I expect one example from you now. Any one example.
IC engine.
IC engine. Okay. I see. Which component? Can you concentrate on particular component?
Piston.
Piston. Okay. Okay. So in case of piston also, repetitive type of stresses will get induced. You can mute yourself now. Thank you.
Yes, sir.
Okay. Very basic example I will take. पाण्याचं दार धरताना जे फावडं किंवा खोरं वापरतो आपण त्याच्यामध्ये कुठल्या टाईपचे स्ट्रेसेस इंड्यूस होतील रिपिटेटिव्ह ओके त्यात पर्टिक्युलर टाइम पिरियड पुरतं म्हणतोय मी ठीक likewise where the cyclic stresses are induced that means the stress will increase or decrease will become zero will become negative that is compressive and tensile that type of stresses you are going to call as a fluctuating type of stress okay so many examples we have taken and just Akash has helped us to have some examples also of this repetitive type of stresses. So in case of connecting rod and this crankshaft, this repetitive type of stresses will get induced because basically piston is going to compress to the charge, then the charge is going to compress to piston. That is while we are going to compress the piston at that time or compress that charge with the piston, then compressive stresses will get induced. Okay. And when we are going to discharge it, okay, in that case also the fluctuating, that is stress is going to increase and decrease. Maybe that it may become negative or it will remain to the one side only as a compressive only. But intensity of stress is going to change. Likewise, in case of this connecting rod, the stresses will get transferred to the crankshaft. Basically, load is going to transfer to the crankshaft, and this crankshaft will undergo to the stress, and which are in repetitive nature. That is, first of all, it is undergoing to the compressive, then afterwards tensile, and that's why you can see here the catastrophic failure and fatigue failure will occur in case of this crankshaft. So here you can see this crack will get initiated at the bearing point, and later on this crack gets propagate. Now this region, I'll say this is the region where this crack gets propagate. And here it has started. This oval shape is the point where the crack has started, initiated. Later on it gets propagation. That is called as propagation zone. Okay, and sudden failure occurs to this region. This propagation and sudden failure, it may take very less time as this sudden thing or these things happen suddenly. Okay, but this initiation and propagation, it may have some time delay, and this what we have discussed about is the condition monitoring and fault diagnosis. That technique gives us idea that crack has generated and it is about to initiate, so that we can take the preventive measure and we can stop this failure. Okay, so that is part of this condition monitoring and fault diagnosis. But fatigue failure will have these three stages, that is initiation, propagation, and later on complete failure. Okay, now one more example we can take. This is one part which is used in hammer. Okay, like we have taken example of stone breaker. In that stone breaker, that hammering action takes place, and this failure has occurred in that hammer. Here you can say the propagation, or sorry, initiation of that crack has started at this point. Okay, and later on this crack gets propagate to this region up to this point. I may not be able to cover a whole area with this shape, but this crack gets propagate, and this is what the sudden failure part. This part is failure which is occurring suddenly. Okay, hope you have understood all these things. Same way, this is the other, that is component which has get failed and which has converted into two parts. This is one part and this is second part of that. That is here the crack has initiated and it gets propagate and sudden failure will get occur. Okay, so these are the three stages. Now out of that, if we are going to say here, this is crack generation region, this is propagation, up to this point, and this is sudden failure. Okay, so this is what the mechanism of that fatigue failure, where the fatigue failure occurs in these three stages. Now let me ask one question, that have you seen such type of failure? Now this is one more part which has elaborated, okay, and under microscope how the failure gets occur and how the components looks like has explained. Now here this crack has started at one end, it gets propagate, and later on the end, that is sudden failure, occurs here. Okay, the start has mentioned, then progression has mentioned, and end of that failure has mentioned. This progression region has elaborated here and has magnified that we can see how the failure gets occur. Okay, so that is separate part where the understanding of this fatigue failure can be done with the help of this microscopic study. Any question about the fatigue failure? There may be long question in exam to describe what is the fatigue failure, what are the characteristics of that fatigue failure. Okay, more precisely, the examiner may ask that explain fatigue failure or explain the stages of fatigue failure. In that case, it is good that if you are going to draw one diagram and you are going to mention the stages, three stages of that fatigue failure, okay, and if you describe it, and if you are going to write the characteristics of that fatigue failure, then all the characteristics which we have learned in previous class as well as some characteristics we have learned in this class also, that you can describe point wise. And if you are going to write your answer point wise, it will carry more weightage, you will get more marks. Okay, any question? Have you understood each and every part of this lecture? Hello? Will you respond, please? Pratik Deshmukh. Pratik Deshmukh.
Yes, sir.
You understood?
Hi, yes, sir.
Okay, can we move further now? So next point which we are going to see is the what is the region that the crack gets initiated, or what is the possible region of a component where the crack gets initiated, and that part is nothing but the part where the stress get concentrated, and that crack or failure may start at that point where the more stresses are generated in any component. Now, more stresses are generated, it means that because stress is what simply, if you are going to explain it by mathematics, then stress is nothing but the force divided by area. That is the simple mathematics of the stress. Now, if you are going to see the physical significance of the stress, it is nothing but the induced what resistance inside that material, any material. Inside that material, it is a resistance to externally applied force. What that external applied force is trying to do, that external applied force is trying to move that molecules away from each other, and that molecules of that component, if they are not willing to separate, then they are going to have some attractive force, and that molecules are applying that attractive force, and that attractive force is nothing but because as they are going to apply the attractive force and they are going to stick with each other, then the stress will get induced. That means they are resisting to the externally applied force which is trying to separate out there. So that resistance is nothing but the stress. Now, where it is possible to have that resistance as a weak, because when we are going to say that resistance is strong, then that component will withstand to that external applied force. But where it will get become weak, that means the resistance is going to become weak, where the stress level will get increased. That means they are more stressed. That molecules in that region are more stressed. They have to have together with each other. Okay, and more force has to be applied by them to be together, to remain together. And which is this region, because in that region only it is possible to have the breakage or initiation of that crack, and that is called a stress concentration. Now that stress get concentrated. Now here you can see this diagram where plain plate is undergoing to the stress. That is, on this plain plate we are going to apply force from one side, and naturally when we are going to apply force from one side, and if you are going to apply sufficient resistance from the other side, then that force will get applied to the other side also. Let me explain once again. एक प्लेट आहे, त्या प्लेटला एका साइडनं आपण फोर्स अप्लाय केला. ओके, that force will say as a F. हा जर F एवढा फोर्स आपण अप्लाय केला आणि दुसऱ्या साइडनं काय केलं की त्याला आपण एका रिजिड बॉडीला कनेक्ट केलं, ही एक पहिली केस आहे. किंवा दुसऱ्या साइडनं आपण सफिशियंट रेजिस्टन्स प्रोव्हाइड केला आहे एक्सटर्नली अप्लाइड फोर्सला. आणि म्हणजे आपण असं कन्सिडर करतोय की दोन्ही साइडला सेम अमाउंट ऑफ फोर्स विल गेट अप्लाइड. हा जो फोर्स आहे एफ अप्लाय केलेला, हा फोर्स नॅचरल आहे, ह्या प्लेट मध्ये स्ट्रेस इंड्यूस करेल. तो स्ट्रेस किती असणार आहे? द स्ट्रेस फॉर्म्युली विच वी नो इज दॅट फोर्स डिवाइड बाय एरिया, divided by cross sectional area of that plate. That will be the stress sigma. Which type of stress again you get induced? that will be tensile type stress. Okay. This tensile type of stress will get induced in that component. Okay. So this force divided by cross section area. Now my question is that if we are going to take this cross section area at this point, and if we are going to take this cross sectional area at this point, whether it will get deeper from each other or same area we can consider as A, suppose here it is 10 millimeter square. Can we take this as the same here as a 10 millimeter square, or it will get reduced or will get increased? वैभव
सेम
भोसले.
नसणार सर
Yes, what?
सेम नसणार
सेम नसणार आहे. ओके. कमी किंवा जास्त? भोसले वैभव किती असेल? हा मोरे सांगा तुम्ही किती काय असेल?
कमी असेल इकडं
कमी असेल. वाय?
तिथं मटेरियल कमी आहे म्हणजे
इथं इथलं मटेरियल रिड्यूस केलेलं आहे. मटेरियल कमी केलंय म्हणजे इथं होल आहे ह्या प्लेटला.
हा
त्याच्यामुळे ते होलचं जे मटेरियल आहे ते मटेरियल तिथनं निघून गेले. दॅट्स वाय देर विल बी ओनली this area plus this area, right? And which is naturally less than this area. बरोबर आहे? Okay. Then whether we have changed this force, applied force change केलाय का आपण? ह्या रिजन पुरता अप्लाइड फोर्स वेगळा आहे आणि राहिलेल्या रिजन पुरता अप्लाइड फोर्स वेगळा आहे. योगेश पाटील, you unmute yourself. Yogesh Patil and Sachin Kengar, you please unmute yourself. Hello? Yogesh Patil, please unmute yourself.
Yes, sir.
When you have joined?
Sir, range problem, sir.
Range problem. Okay. Have you understood what we have seen right now? And Kengar? Sachin Kengar? Will you unmute yourself? Okay. Now, as we are not going to change this force, but area is going to change. That is nothing but if suppose at this point A, area, not A, we have used A as a area, nomenclature for the area. So we'll say this point as a M point and this point as a N point. So as M is the higher area, we'll say it as A1, and at N point it is A2. So A1 is suppose 20 and A2 is suppose 10, exactly half of that. But what will happen if you are not going to change F? Whether this sigma 1, where we have calculated it as at point sigma 1 which we have calculated at point M will be differ from this sigma 2 which we will calculate at point N. We'll say it as a sigma 2 which we will calculate at point N, and this area will be A2. So definitely this sigma 1 will be less than sigma 2. Am I right? What the mathematics shows? If A2 is less than A1, definitely sigma 1 will be less than the sigma 2. Am I right? Because
Yes,
F is
sir.
going to remain constant, right? Okay. So in this plate only, these two stress level will be generated. That is, sigma 2 will be higher than sigma 1. This higher stress, if we are going to correlate it, if we are going to have the streamlines of the stress, okay, it doesn't happen like this, but we are going to just have this simulation of the stress as a streamlines. You might have studied what the streamlines are in fluid mechanics. You might have conducted experiment also to calculate Reynolds number. Whether you have conducted that experiment. एक कलर्ड वॉटरची स्ट्रीम आहे, त्या स्ट्रीम आपण लॅमिनार फ्लो मध्ये जर टाकल्या तर आपल्याला त्या कलर्ड वॉटर मध्ये अशा फ्लोच्या लेअर दिसतात. ओके, आणि त्याच्यामध्ये जर असं एखादं ऑब्स्टॅकल टाकलं आणि ते ऑब्स्टॅकल जर सपोज रेग्युलर शेप मध्ये असेल, म्हणजे सर्क्युलर, ट्रायंग्युलर, इलिप्टिकल असं असेल, तर त्या स्ट्रीम लाईन्स जर तो फ्लो लॅमिनार असेल तर त्या स्ट्रीम लाईन्स अशा साईडने जातात त्याच्या. ओके, तसंच आपण समजूया की ह्या स्ट्रेसच्या स्ट्रीम लाईन्स आहेत, स्ट्रेस इंड्यूस होणार आहे, आणि जिथं कुठं ऑब्स्टॅकल येईल तिथं त्या स्ट्रीम लाईन्स काय करतात की आपण दुसऱ्या साईडने जातात. ओके, दिस इज फ्लो ऑफ वॉटर सपोज वेअर वी आर गोइंग टू पुट धिस सर्क्युलर स्टोन इन बिटवीन दॅट फ्लो. ते पाणी काय करेल की दिस इट विल नॉट गेट स्टॉप हिअर, डेफिनेटली दॅट विल गेट फ्लो इफ यू आर गोइंग टू प्रोव्हाइड द ग्रेडियंट. म्हणजे आपल्या इकडं जो स्लोप आहे एन साईडला, एम कडून पाणी वाहत असेल आणि एन साईडला उतार आहे, तर ते पाणी स्टॉप होणार नाही इथं, तर ते पाणी त्या दगडाच्या साईडनं जाईल. आणि साईडनं जात असताना इथं काय होईल, ह्या रिजन मध्ये त्या पाण्याचं कॉन्सन्ट्रेशन वाढेल. बरोबर आहे? वेअरएज हा जो एरिया आहे इथं त्याला पाण्याला फ्लो व्हायला एरिया जास्त आहे, तिथे त्याचं कॉन्सन्ट्रेशन कमी असेल. And that type of situation is called as stress concentration. Whereas if the stress concentration get increased, then there is possibility of failure. Right? Because why? Because the possibility of failure get increased because the stress which get induced is higher than the other region stress, and that's why we have to take care for such type of situations where the stress concentration get occurred. And this stress concentration, we later on will read this, this same thing has explained here, which I have explained right now. Okay, just it has written. So one more example as explained on this slide. In this slide also, if suppose we are going to have sudden change in cross section, then the stress will get concentrate at particular region, and that particular region is nothing but the region where the sudden change has occurred at this point. Okay, at this point the concentration of stress occurs. So what is the remedy for that? If we are going to have sudden change, step if you are made, instead of that, if you make it chamfer, then definitely that chamfer will allow that streams smoothly to be concentrate or to be flow to the next region, which is less than the previous, or area which is less than the previous area. such type of things may happen in case of notches which you are going to provide on some parts. These notches, basically in case of threaded parts, these notches may be generated, or some components are there where the notches are generated. That is the geometrical requirement of that component where the notches are generated. So if you want to reduce that stress concentration, then instead of having one notch, you can have the other notches that follow to the main notch, so that that streamline will become more fluent. Or here one more remedy has explained that we can drill the holes at beside the notch, so that the stress concentration will get reduced. Whereas we can remove that area, this shaded area we can remove, and we can again make these streamlines to be flow smoothly. Okay, same thing which I have explained here has explained here also. That is, we are going to make the chamfer. Or other remedy is that we can make some groove here, so that the streamlines will become smooth. And only thing which we have to do is that the streamlines should not get gathered at certain point. They should not concentrate at certain point. They should have smooth flow, and that is called as remedial to the stress concentration. Hope you understood all these things. Do you have any question? Hello? Should I explain it once again?
Yes, sir.
Okay. स्ट्रेस कॉन्सन्ट्रेशन म्हणजे काय की स्ट्रेसचा झालेला वाढलेली व्हॅल्यू, त्याला कॉन्सन्ट्रेशन म्हणू आपण. ओके, म्हणजे हा जो रिजन घेतला, या रिजन मध्ये स्ट्रेस म्हणजे आहे फोर्स डिवाइड बाय एरिया. त्याच्याबरोबर हा पण रिजन आहे ज्याच्यावर सेम फोर्स अप्लाय केलाय पण एरिया रिड्यूस झालाय, कारण इथं आपण एक ह्या प्लेटला होल पाडलं. एरिया रिड्यूस झाला, सेम फोर्स असेल तर स्ट्रेस डेफिनेटली वाढणार, कारण डिवायडर कमी झाला ना. तो डिवायडर कमी झाला, फोर्स तेवढाच राहिला, म्हणजे ही व्हॅल्यू वाढली, म्हणजे स्ट्रेस वाढला. ह्या वाढणाऱ्या स्ट्रेसला आपण स्ट्रेस कॉन्सन्ट्रेशन म्हणतो. आता हे स्ट्रेस कॉन्सन्ट्रेशनचं सिम्युलेशन आपण ह्या फ्लो स्ट्रीमलाइन्स मध्ये केलंय. आता ह्या ज्या स्ट्रीमलाइन्स आहेत, ह्या स्ट्रीमलाइन्स असं समजू आपण की ह्या स्ट्रेसच्या स्ट्रीमलाइन्स आहेत. प्रत्येक स्ट्रीमलाईन जी आहे ती या साईडला म्हणजे उजव्या साईडला आणि डाव्या साईडला ओढल्यामुळे तयार झालेली ही स्ट्रीमलाईन आहे. ओके, आता ह्या स्ट्रीमलाईन आहेत, ह्या स्ट्रीमलाईनला जर इथं आपण होल पाडलं तर डेफिनेटली त्या स्ट्रीमलाईन तुटत नाहीत. जर तुटणाऱ्या असत्या तर हा पार्टच वीक झाला असता. ओके, म्हणजे कपड्याला आपण होल पाडल्यानंतर कपड्याचे धागे तुटले जातात तिथं, तसं त्या स्ट्रेसच्या स्ट्रीमलाईनचं होत नाही. तर इथं काय झालं केलं जातं की ह्या स्ट्रीमलाईन्स एका ठिकाणी कॉन्सन्ट्रेट होतात. मग त्या कॉन्सन्ट्रेट झालेल्या स्ट्रीमलाईन्स म्हणजे पाणी जे असं इकडं फ्लो होऊन जाईल, पाणी कमी होणार नाही, फक्त ते दुसरीकडून वाट बघेल त्याची वाट, आणि त्याला जिथून वाट मिळेल तिथून फ्लो होईल ते. तसं ह्या स्ट्रेस स्ट्रीमलाईन्स पण तशा फ्लो होतात. आणि त्या स्ट्रेस असं आपण मानतोय, ओके, हे असं स्ट्रेस होतं असं नाही, हे फक्त सिम्युलेशन करायला लागलोय आपण. ओके, फॉर बेटर अंडरस्टँडिंग, आपल्या अंडरस्टँडिंग आपण हे सिम्युलेशन करतोय. फक्त आपल्याला एवढं कळतंय की ह्या रिजन मध्ये आणि ह्या रिजन मध्ये स्ट्रेस वाढलेला असतो ह्या रिजन पेक्षा. ओके, मग काय काय कन्सिडर करतो आपण की ह्या ठिकाणी स्ट्रेस कॉन्सन्ट्रेट झालाय असं समजतो, म्हणजे या स्ट्रीमलाईन कॉन्सन्ट्रेट झालेत असं समजतो आपण. त्याला म्हणायचं स्ट्रेस कॉन्सन्ट्रेशन. आता हे जे झालेले स्ट्रेस कॉन्सन्ट्रेशन आहे, त्या स्ट्रेस कॉन्सन्ट्रेशन रिड्यूस कसं करायचं, कारण ज्या ठिकाणी स्ट्रेस कॉन्सन्ट्रेट होतो त्या ठिकाणी फेल्युअरचे चान्सेस जास्त आहेत. म्हणजे आपण मागाशी जे म्हटलं की रिपिटेटिव्ह टाइप ऑफ स्ट्रेसेस जर जनरेट व्हायला लागले तर फेल्युअर ऑकर्स वेअर द सडन चेंज इन क्रॉस सेक्शन ऑर वेअर द स्ट्रेस गेट कॉन्सन्ट्रेट. त्या ठिकाणी क्रॅक जनरेशनची शक्यता सगळ्यात जास्त आहे. मग ते क्रॅक जनरेशन होऊ नये त्याच्यासाठी आपल्याला काय केलं पाहिजे की स्ट्रेसचं कॉन्सन्ट्रेशन कमी केलं पाहिजे. मग तो स्ट्रेस कॉन्सन्ट्रेशन कमी करण्यासाठी आता ह्या ज्या पॉसिबल वेज आहेत किंवा पॉसिबल ठिकाण आहेत जिथे स्ट्रेस कॉन्सन्ट्रेशन होतो ते कुठले कुठले आहेत. एक आहे सडन चेंज इन क्रॉस सेक्शन. म्हणजे या ठिकाणी आपण जर स्टेप तयार केली एखादी कंपोनंटवर तर तो सडन चेंज इन क्रॉस सेक्शन आहे. म्हणजे इथला एरिया वेगळा आहे, इथला एरिया वेगळा आहे. डेफिनेटली सेम फोर्स जर अप्लाय केला तर इथला स्ट्रेस वेगळा येईल, इथला स्ट्रेस वेगळा येईल, कारण एरिया दोन वेगवेगळे आहेत. पण या रिजनला काय होईल की हा स्ट्रेस जो आहे हा स्ट्रेस कॉन्सन्ट्रेट होईल. ते स्ट्रेस कॉन्सन्ट्रेशन कमी करण्यासाठी त्याला जर आपण फिलेट एरिया केला किंवा त्याला जर आपण चॅम्पर केलं तर काय होईल की तो कॉन्सन्ट्रेशन कमी होईल. म्हणजे स्ट्रेसच्या ज्या स्ट्रीमलाईन आहेत त्या स्मूथ फ्लो होतील. म्हणजे हे समजा टेन्साइल स्ट्रेस आहे तो असा स्मूथ मोठ्या एरियाकडून छोट्या एरियाकडे ट्रान्सफर केला जाईल. म्हणजे छोटा एरिया केपेबल असेल स्ट्रेस घ्यायला तर डेफिनेटली तो विस्टर्न होईल. तो जर केपेबल नसेल तर तुटून जाईल. ओके. तसंच नॉच काय पार्ट मध्ये आपल्याला नॉच तयार करायला लागतात. त्या नॉच मध्ये काय होतं मग ह्या सगळ्या स्ट्रीमलाईन जर इथं आपण ड्रॉ करायचं म्हटलं तर ह्या एरियामध्ये त्या स्ट्रीमलाईन सगळ्या कॉन्सन्ट्रेट होतील एवढ्या एरियामध्ये. अर्थात त्या नॉचचा एरिया वगळून. त्या एरियामध्ये त्या सगळ्या कॉन्सन्ट्रेट होतील. बरोबर आहे. इथे डेफिनेटली स्ट्रेस कॉन्सन्ट्रेशन वाढणार आहे. हे स्ट्रेस कॉन्सन्ट्रेशन कमी करायला काय करायचं की छोट्या छोट्या नॉच पाडायच्या त्याच्या साईडला. जे मेन नॉच आपल्याला रिक्वायर्ड आहे त्या साईडला छोट्या नॉट रिक्वायर्ड नॉच पाडायच्या. त्याच्यामुळे काय होईल की तो ग्रॅज्युअली तो एरिया कमी 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 होत जाईल आणि ते स्ट्रेसचे कॉन्सन्ट्रेट व्हायचं आहे. डेफिनेटली इथं होणारच आहे. पण इथं होत असताना ह्या सडन चेंज एरियामुळं सगळ्या स्ट्रीमलाईन्स इथं रश होतील. त्या स्ट्रीमलाईन्स रश न होता त्या इथूनच स्टार्ट होतील कमी 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 व्हायला आणि इथनं परत स्मूथ बाहेर पडतील. ओके. जस्ट लाईक वॉटर फ्लो आपण त्याचं सिम्युलेशन करतोय. वॉटरला फ्लो करण्यासाठी जसं आपण कॉन्सन्ट्रेट करू तसं इथं होतंय असं समजू. ओके. किंवा तो एरिया रिमूव्ह करायचा त्या नॉचच्या साईडचा, किंवा म्हणजे आपल्याला नॉचच्या ऐवजी तो रिमूव्हल ऑफ एरिया करायचा, किंवा त्या व्ही नॉचच्या साईडला आपण छोटे छोटे होल पाडले तर तिथं स्ट्रेस कॉन्सन्ट्रेट म्हणजे स्ट्रीमलाईनना अगोदरच समजेल, त्या स्ट्रेसला अगोदरच समजेल इथं एरिया कमी आपण कॉन्सन्ट्रेट झालं पाहिजे. मग इथनं ते स्टार्ट होईल आणि तो स्मूथ होईल एरिया. तसं काही ठिकाणी कीवेज असतात. ते कीवेज जर इथं पाडले तर जनरेट होणारा जो स्ट्रेस आहे आपण सर्क्युलर स्ट्रीमलाईन्स काढले तिथं आता त्या सर्क्युलर स्ट्रीमलाईन काय होतील की इथं कॉन्सन्ट्रेट होतील ह्या रिजनमध्ये, या रिजनमध्ये. ओके. मग त्या कॉन्सन्ट्रेट न होण्यासाठी आपण जर त्या साईडनं दोन होल पाडले, त्या कीवेजच्या साईडनं होल पाडले तर काय होईल की इथूनच त्या स्ट्रीमलाईन्स कमी व्हायला सुरुवात होतील. म्हणजे त्या स्ट्रीमलाईनचा स्मूथ फ्लो स्टार्ट होईल. नो डाऊट तो एरिया आपण वीक करतोय. ओके. त्याच्यासाठी आपण दुसरा पर्याय वापरू की काही ठिकाणी त्या एरियाला सबस्टिट्यूटरी एरिया देऊ, तो एरिया वाढवू. म्हणजे ह्या डायमीटर जर 3 mm येत असेल तर तो MM आपण 6 mm करू. ओके. पण स्ट्रेस कॉन्सन्ट्रेशन कमी होईल इथलं. इफ वी आर गोइंग टू गेट द डायमेन्शन ऑफ दिस शाफ्ट ॲज अ 3 mm diameter, we'll keep it as a 6 mm diameter, no doubt. Okay. Where we have kept or we have increased the factor of safety. कॅल्क्युलेशन न 3 येत असेल तर आपण 6 घेऊ. ओके. आणि त्या ठिकाणी होल ड्रिल करू तर ते स्ट्रेसचं जे कॉन्सन्ट्रेशन आहे ते कमी होईल तिथं. आणि दॅट इज कॉल्ड एज रेमिडियल measures for the stress concentration. Any question? समजले?
Yes, sir.
Okay. There will be, or there may be, not I will say will be, there may be question in exam also. Explain what is stress concentration and what are the remedies on stress concentration.